Hello, everyone, and welcome to this Varnish webinar. It is called 10 Tricks for Getting the Most Out of Varnish. Right now, we're 1 minute past, and I see we have 14 people joined. I think I'll wait a few minutes until I start, just in case. I can say a few things. First, the questions and answers pane or tab or button gives you a way of sending questions to me during the presentation. And if you have any questions or comments, you can enter them at any time, and I will pick and choose what to respond to as I go. Typically, if there's a short question or comment which is relevant there and there, I will just answer it. But if it's a long questions, which will take a few minutes, I will probably wait until the end of the lecture or the presentation to answer that. We'll see what happens and see how the time schedule is right there and then. We have 10 points to go through, so that's approximately 5 minutes per point, and then we have 10 minutes for question at the end. Of course, if we finish before, that's completely fine. And hopefully I will be forgiven if we go past the hour. Let's not try to do that, and let's get started. This is a picture of me pre-COVID. I've gotten a new title, Director of Core Development, which means that I'm responsible for the Varnish daemon and associated tools, and I'm leading the team of C developers who write these tools. Yeah, so let's get started. First of all, this cache invalidation using keys or tags is one of the unfortunately not so much used ways of invalidating caches, but it's been recommended by many people, and I would like to show how to do this today. The subtitle Optimal Caching requires a good cache invalidation strategy. It refers to the fact that if you want to have an optimal use of your cache, you don't want to fetch anything from the backend, which is the origin server, the conventional web server that you have, unless it's changed. And to be able to do that, you need to tell the cache somehow that it's changed. That is usually done through invalidating the content, which is no longer valid. And when this happens and you get a new request for the content, you will get that fetched from the origin. And this, there's several ways of doing it, and the tag-based one is natural, and I'll show how to do that. Okay, so the vmods. Vmod is a Varnish module. I will talk a lot about vmods today, called xkey for Varnish Cache, and then you have ykey for Varnish Enterprise. Marketing was not able to change that naming before it was out, so it's called ykey as a little joke. It stuck. Right, so these two vmods will let you assign keys to any objects or assets which are inserted into the cache. And this is an example of a response. Actually, it's just an extract of a response from a web server where there's a new header called xkey. And in this case, it's shop item something, which means that the owner or the administrator or the programmer who sent this header wants to be able to invalidate all assets in the cache which is related to a specific shop item. Maybe it's a pair of shoes that might get a new picture or a new price or anything like that. And they want to have a way of invalidating all of these items when an update happens. It's very practical. You have other examples like news articles or news items, maybe ads, any kind of element of a web page or a set of web pages which are connected, where you want to be able to get rid of all of them in one go. So the backend has sent this header, also known as a surrogate keys in some instances, to be able to do this. And with Xkey, which is the open source vmod, the header called Xkey is magic. If that header is there, then those, actually it can be a list of items under the Xkey header will be added, but in Ykey you have to be more explicit. And let's see how that is done, right? So it's very little code. This is VCL code, which is the way VCL, the Varnish configuration language, is the way you configure Varnish, as at least some of you know. And in this case, you simply ask the Ykey vmod to add all of the keys from a specific header. Actually, you can have many headers. In HTTP, you can have many headers with the same name and different values. And this particular command here, add header, will take all of the instances of the Xkey header and add all of the keys from those headers. And that might give you a whole lot of keys for each item, but that's allowed. Right. So to facilitate the actual purge, you need to have some more code or some more VCL. And this is one example of how to do it. So let's go through this slowly. We'll see how slowly on the time. Right. So I'll try to draw something here. The rec method purge is, so the method is part of the HTTP request. Typically it's get or put or post or delete. But it can also be purge, and you can configure Varnish to react to a specific method by checking the rec method member here. So, so when you have a request with a purge method, you need to make sure first that the request comes from someone who should be allowed to purge. And in this specific case, we use the client IP, and we check that versus an object called purgers, and that's actually an access control list, which is not shown in this example. There can be other ways of doing it. Maybe you have a shared secret, a password, encoded password. Maybe you have a separate port which is open to connect to, and you can check if a request came on this port where the firewall or something has made sure that it comes from a safe location. Then you can change this test, this if test, to that. So you secure the right to do purchase. Right, so when you pass this if block, you come to two different cases. The first case when there's a Ykey purge, and that's a separate, it's not a magic header, it's simply something that you can use to specify a Ykey. And the writer of this code has decided that that's a good name for the header where you purge it. And in this case, if that header is present, then you call a function called purge header in the Ykey vmod. I don't know if you can, let's see if I can again draw something. Yeah. let's try that. So this purge header function here is a function inside of the work mode, and it will return a number, which is the number of assets which had the key and which is being purged. And then the code continues by sending a string to a synthetic message. So this will, the return synth will create the synthetic page where the receiver of the request, which is the one who sent the request, can see how many objects were actually removed. And then we have the other branch here where you don't have the Y key, then you simply do a purge. And this is a normal purging for Varnish. Then you will actually need to have the URL and everything, which is associated with the actual request when you get this request. And that will remove only a single item. So that's a limitation, but this code that you see here handles both of these cases. So you can have several ways of purging in the same BCL. And this shows too. There are many use cases for this, as I said, and main use case, yeah, I mentioned that, so let's not dwell on it too long. I just need to make sure I can, sorry. Right, yeah. So that was number one. Let's go to number two, stale content when your server is down. The point with this is that sometimes, of course, downtime is always bad, but sometimes you can get away with it. And this is what point number two is about. You should avoid the perceived downtime when you can, when you can't actually avoid downtime of the backend server, the conventional web server. So let's see how we do this. Okay, for this to work at all, you need to have the cache with stuff in it. You need to have a good caching strategy, and you need the cache to be populated. Of course, there might be some assets which are not in the cache, but hopefully the most popular ones will be there, and you can serve them even if your backend is down. Of course, you can't serve fresh versions, but you might be able to serve stale versions when you would rather do that than serve an error. So there are two types of content. You have the content that can be served to a certain point and then should never be served again, no matter what. And then you have the type of content where you want to serve that instead of an error, and that's the stale content. And to be able to do this, you need to do a few steps, not a lot of stuff you need to do. Let's have a look. First of all, you need to make sure that when the time to live and the grace, I'm not going to the grace too much, the time to live plus the grace is the amount of time where an asset is sent to the client without having to first get something from the backend. And these are known to most people, most users, but then you have the keep, which is another property of an object that you insert into the cache. How long should an object stay in the cache even though it's expired? And you do this so you have something to send when all other options are depleted. The keep used to be strictly for 304 handling, so the when the HTTP request comes in, it can have this if not modified header or if modified since, and it can refer to a date or to a e-tag, and then the server can answer 304 not modified, and then you can say, oh yeah, what I have in the cache can actually be served a bit longer. And keep used to be the way of doing that. This stale if error mechanism is an extension of the use of keep. And I would say an even better way of using keep. So let's say that we do this in this code snippet here. We have set the keep time to 7 days without any questions asked. Of course, in the perfect world, you will let the backend or your web developers, and since it's a perfect world, you trust them to give you a keep value, which is then at the time where you can serve the object beyond TTL plus grace instead of an error. This code in itself will not change anything in the normal, when you have normal operation and the backend is working, everything is fine. This particular line will not change anything, but it will change things when you are in big trouble. So, oh no, the backend is down. What do we do? And this is a little bit of code where you actually use this stale content, the keep that you just set up. And here we first see a method called stale if error. This is something that the VCL writer has defined because he wants to call it from 2 different locations. And what it does is that first it checks if the response is a 500 or more, which is the irrecoverable error codes. Sometimes you might want to do it also for 404s in special cases. And it also checks if there's actually a stale object there that you can serve. And in these cases, the VCL writer has decided to revive the object for 20 minutes per half an hour, plus 1 hour, sorry. This means that it will get a new TTL and a new grace value of 20 minutes and 1 hour respectively, but you should adjust this to your needs. So if it makes sense to have these numbers as the new TTL and stale, grace, then that's fine, use that. But you can also actually store something inside of the stale object, which tells your VCL when this object needs to be revived, for how long should it be. This example does not show that, but it is possible because the stale vmod also will give you access to the headers of the stale object. Just have a little bit of water. Right, so when you have revived the object, you need to tell Varnish that it should deliver this object, and then you abandon the request. This sounds very serious, to abandon the request, but it only means that the object that you have there and then is not to be used for anything. You're not inserting it to replace the object that you just revived. The revived object needs to be there so that new clients can get that. And one of the things which is really great with this is that if you have a backend which is not completely down but is struggling a lot, the revive call will make some breathing room for the backend, because this object, which used to be expired, can actually now be served for a while without a new backend request happening for every time a client wants this resource and the backend can't serve it. So in general, this works very well in the cases where you can revive an object, and that makes sense. So when do you need to do this stale of error? You need to do it in the backend response, because sometimes the backend will be down, but it will be able to serve some errors. For example, maybe the backend has a database connection and the database is down. Then the backend will be able to say, I can't serve you this. It's impossible. And then it's up to the cache to revive the object and serve the stale object. And also in VCL backend error. And you can end up there if, for example, the network is down and you can't connect to the backend at all. Then you'll end up with stale if error in backend error. And in both of these cases, you want to call the stale if error subfunction, which you have just implemented. And this is it, I guess. Yep. This works very well. I just want to say finally that, of course, this makes a lot of sense for newspapers, but it can also make sense for large sites like video on demand sites, where there's a file which contains the main catalog with a list of everything, and then many manifest files and previews and video segments and all of the things. That's also a case where it can work. And that brings us to the next point, which is number 3. Store terabytes of video at the edge of your network. Network bandwidth is not free. So this idea of having terabytes of video at the edge of the network, it makes a lot of sense if you're an organization which is spread across the world, and you have a central store of all of the video content, and you use caches to store the, give the data to all of the clients. And of course, the reason why it would or wouldn't work usually has to do with cost. And we would like to encourage you, or I would like to encourage you, to actually think about this as an option, because it seems to me at least that this might be the economical way of doing it. The point is that the network bandwidth between the edge and the client, that's something you need to do every time. You need to pay for that bandwidth, but that might be very small. For example, if you're allowed to put your edge caches inside of the data center of an ISP, that will save you a lot of money because you don't have to pay for housing for your servers, and it will save the ISP a lot of money because having a big cache with lots of terabytes of storage inside of the ISP will reduce the bandwidth need for the ISP and can even increase the quality of service for the customers of the ISP. So you can do this with Varnish massive storage engine, and I'll just show you the configuration file here on the next slide. The video segments in the massive storage engine is not stored as files on the file system. That's because file system have guarantees, and they need to do locking, which we don't have to in the massive storage engine. We can do just the amount of locking which is necessary, and we can keep control of everything. And that's why you specify the configuration of the massive storage engine like this. Here, in this example, we have 2 books. A book is a database essentially about what is where. And in book 1, you have a database size of 2 gigabytes. The database is what goes where. And then you have a store. And in this case, in this example, you have 2 NVMe drives, which are mounted on under MNT. And we have put the book and the store on the same location. So on each of the drives, we have 1 book and 1 store. And in this example, we have 800 gigabytes worth of data in each NVMe. And I'm insisting on NVMe here because nowadays that's what you should use for practically everything. The reason that I'm insisting on this is that Intel recently had a webinar with us where they announced the fact that they had been able to deliver 383 gigabits per second from a single machine. It's a dual socket computer. It has 256 gigabytes RAM, and the active set, the data sets where the video segments were taken from, was 3.2 terabytes, and the access pattern was actually random, which means that all of the content in this dataset was the same, of the same popularity, which meant that the memory hit rate was very low, but still they were able to push, with the help of Varnish Enterprise, 383 gigabytes from this single computer. It had 4 100 gigabits network cards, and this is about how much you can possibly hope to do. Of course, such a configuration and testing setup needs to be at least somewhat, what's the word? Artificial, maybe, yeah, synthetic. And real world conditions will not allow you to do this with the same hardware, simply because some clients have packet losses, some clients are slow, you get effects from the network itself. But you can get, just looking at the hardware, these kinds of speeds. And when you are at this point, you really, really don't want to pay for those 383 gigabytes, both in and out of your data center, and on the other side, your main data center. So yeah, this was completely shameless from our side, of course, but the way I see it, there are some good opportunities to save a lot of money from having data on the edge. Typically, the larger you are, the larger organization you are, the more it makes sense to put a lot of data around the world. Right, let's go to the next point. Knock, knock, who's there? It seems to me I spent half of the time for just 3 points. This is okay, because the first one was quite large. So the point with this point, number 4, is that you want search engines to index your content. They are your friends, and you want to give them all you have, which is nice. And if you have a paywall, you want to give them the actual article, but you don't want to give the article to others. In other words, you want to serve the real content to search engines, but you want to serve the real content only to customers and search engines. So what do you do? Each engine, search engine, provides information on how you can verify that the request comes from a search engine, and the typical pattern is this. You get some user engine string, for example, containing Googlebot or Bingbot, and that's when you know that the request might be from a bot, but you're not sure, because it might be some guy who has changed its user agent header and wants the free content. So what do? You do something called forward confirmed reverse DNS. Essentially, you take the IP address and then you do a reverse DNS lookup, and this will give you a name. This name you check. Maybe it ends with Google.com. Great, this is Google, but that's not enough, because the owner of the IP can actually decide what you get from this reverse lookup. So you need to look up the name and go back again and see if you get the same IP. And if you do that, you actually have verified that this is Google or Bing or someone else, and you can serve the special content, the non-paywalled version of your articles. As always, there's a VCL for this, but in this case, there's a VCL file that we provide for you in the Varnish Enterprise distribution, and it's called Veribot. And it needs a bit of configuration, not a lot, but a bit. And it starts with including the verybot VCL, and then during VCL init, as some of you might know, VCL init is a subfunction that is run once when you load the VCL. And in this init function, you have to tell verybot. So what happens inside of verybot is that it creates a few objects. You can see the two here in the VCL. It's a VB underscore UA underscore filter and the other one. And you need to add some information into these objects about what you consider to be the legal bots. And this is straightforward, of course. It is documented how you should do this. And essentially, this is it. When you've done this, you know that any client claiming to be a bot without being it will get an error instead of anything else, which is essentially what you want to do. There are some engines which don't have this requirement to verify. For example, DuckDuckGo will crawl from the same IP address to all sites, which means that you can just check the IP. And to be able to do this, you need to have the real IP of the client. So if you have a special kind of load balancer in front of Varnish, which you don't need usually, you need to make sure that it can provide the actual IP for you. Right, so this is the verybot. Give the search engine what they need and give it only to them and the subscribers to your service. Yeah. Right, then we have number 5, cache the uncacheable. And the point here is that when you are a cache, you only want things which are truly public in the cache. I mean, that's the only safe way of doing it, is what we have learned. But you can actually have semi-private or even fully private inside of the cache if you're really careful. And one of the ways of being really careful is to use JSON web tokens. And you get the most out of this if you use semi-private content. So that's, again, it's the example of the paywall or the articles which some have paid for and other haven't. Let's see how this is done. So a JWT, JSON web token, consists of some payload data, which is signed. At least there are variants of JWT, but let's focus on this. And the point with having something signed is that you know that someone with a secret created this JWT. It can be the client, it can be yourself, it can be someone else who has the secret. And you know that this particular version of the payload is authentic in the sense that it was made by someone having the secret. And handling such JWTs is, of course, there are many frameworks for doing it. And now it's been for a while though, there's a way in Varnish to do this. And it's very straightforward. In this case here, we assume that the JWT is inside of the authorization header, and you go through some steps. First, you parse it, and then you'll know if there's some error in the way the JWT is formatted or created. And in this case, you can serve a synthetic error. This is a reasonable way of doing it. And then you set the key. So it's assumed that the Varnish VCL has the key. Secret is just a very stupid key. It should probably something long and obscure or randomly generated here. and then you verify it. And when you've gone through these steps, you know that the clients claim the information which is, or the payload from the JWT is authentic. The claim is legitimate, yes. So it's legitimate. This was the best Creative Commons licensed picture I found. And the point is, as I said, you have verified the token. You know that the client has a secret, or someone made it and the client just holds the JWT. Either way, in the case where you have a paywall, you can serve the content or you can continue with the processing. And the backend doesn't have to know. Of course, the Panda doesn't need to know that it's carried by something which is not actually a Panda. It just needs to be carried. And in this case, the web server just needs to get the request when it's legit. I don't know if the analogy was so good, but it's a Panda. So I took it. Anyway, you can gain the most from this technique if you have content which is shared by many people. So then you'll have content inside of your cache which is servable to some clients, but not all of them. And that's the idea of this. Point number 4, I guess. Yeah. 5. Yes, we did 5, just a bit after schedule. Great. Let's go to cookies. Everybody loves / hates cookies. If you're a cache, you typically don't like them a lot because they will destroy your hit rate. So instead of cursing these cookies, you can take control and you can handle them inside of Varnish. First, before I show you, well, the main point will be that the JWT and cookies works hand in hand, but I'll just show you some of the things that the cookie vmod can do. This example is very straightforward. You can see that the cookie is being parsed by the cookie vmod with a cookie.parse method. And then you have some writing in red and some writing in blue. You typically use one of them. You can either just delete a cookie, and that's what the cookie delete does. Or you can say, yeah, I only want these two. For example, session ID and PHP session ID. And then when you have done this, this is essentially filtering or cleaning up the cookie. Then you can ask the cookie vmod to get the new cookie header that is the filtered version of what you had. And then finally, in this example, you might actually have an empty string because maybe there was just the cookie2 header and you deleted it, or maybe the two special ones that you wanted to keep weren't there at all. So then you can remove the cookie. So that's just basic cookie handling in the cookie vmod. You can also pick out a value from a cookie. Here we use a constant string instead of the cookie header, but typically you will use the cookie header. And you can get out one of the values here. So std log is just used as an example. Typically you want to continue with processing of the cookie after you have extracted a particular value. So let's see what happens with the JWT. A cookie can contain a JWT. You can look at this as a message to yourself that is being stored in the client's browser. And yeah, in this example, it can say, I have the right to read articles on yoursite.com, and I can prove it. And the proof is in the signature of the JWT. So in this example here in the code, you can see that first the cookie is being parsed. You pick out the cookie header, and then you put it into the cookie vmod. It parses it. and then you take out the particular cookie that you want from the cookie header, and you start with the code that I showed you on the JWT bit, where you start parsing it, and then you need to add the secret, and then you need to verify it. And in this way, you can get what you need. And of course, one of the main points here is that you can have one cache node generate JWT and give it, give a client which has just proven that they have the right to see the articles. Maybe you checked it by using a server, login server behind you, and then Varnish can create a cookie header using the JWT vmod, and you can send that as a set cookie header to the client who just authenticated. And the point here is that the backend doesn't need to know. You can have one microservice being the login server, which provides all of the functionality about who can read what, and then you can have another backend which doesn't know anything about users, and it can provide the articles. It can actually also, you can throw in a little trick where the backend, the second backend, can serve different kinds of content depending on if you are authenticated, that is, if you have a paying customer or not. Right. 7, yay. This is a good one. Respond to DNS changes. And depending on how much Varnish you know, you can typically come with one of these two questions. What doesn't Varnish do that by default? And or what? You can do that with Varnish. And both are natural. So let's talk a little bit about backends in Varnish. Yeah, so stock Varnish without any vmods will take a backend connection definition like this one, and it will compile the VCL, and then during compilation it will look up the name, and this is your backend. The backend will, in this case, become an IP address and a port number that's been looked up once. If the DNS changes somehow during the running of Varnish, this VCL will not notice. You need to actually reload the VCL to get a new IP address. And if there's more than one IP address behind the name, then compilation will fail. And that's because the backend is exactly that one backend that you can connect to, and not several. If you want several backends, you need to have a director. And our go-to vmod, which provides dynamic backends, it's exactly that. The main use case, there are variants of this, of course, is to provide a director. In this case, we have API pool, so in the code here, you create an object called API pool from the name api.example.com, and that name might resolve into many IP addresses, and that's fine. And the director will give you one of these backends every time you resolve it. And you can do that. You can set the backend in VCL receive. You can also do it in VCL backend fetch in a slightly different way. And if it turns out that Varnish needs to make a new connection to any of the backends under API example.com, then the go-to director will give you one of them. And yeah, that's about it. There are other ways of doing it. There are tons of options and configuration in GoTo, but for most cases, this is what you need. This exemplifies how Varnish is just not a cache. It's also can be a load balancer or a router, and it can do various business logic that I just showed you with the JWT and Cinder. Right. Yeah, those were the dynamic backends. Let's go to number 8. Automatically manage memory usage. This solves the main Varnish headache for many users. It's yeah. The main purpose of a cache is to use memory for caching. Unfortunately, in the system, lots and lots of things are going on at the same time, and as server runs, its memory usage might change too. So having something reasonable can be quite hard. And this bit is about making this easier. And one of the points here, new features means more configuration. No, it doesn't always. And this is one of the cases where you can actually get away with configuring less because you have the memory governor doing the work for you. And this picture here is, well, it's a very simplified picture of what's happening in a pre-memory governor case. You have set up the purple bit in the bottom. That's how much cache you have configured in Varnish, and it consists of the bodies and headers of all of your items. And I got a question. I will come back to that after I finish the lecture. It's about the go-to mode. And okay, so back to the MSE question. Picture. There are things inside of Varnish will take more or less space depending on many factors. One of them is, of course, how many connections are going on. But there are many other things which can also change. For example, the data structures will take more space if you have many small items or objects than if you have a few big ones. After the memory governor, you get this picture, and you can see the bold line, horizontal line, is higher up, and that's what you specify with the memory governor. You say, I want Varnish to use this much memory, and the result is that the cache payload, the purple bit at the bottom, will adjust accordingly. These blocks are out of proportions. Normally, the cache payload will be a very big percentage of everything. So the effect is not as big as it seems on this picture, but it can be quite significant. And the memory governor will make things easier. Right, so let's be a bit concrete. There's a new parameter called memory target that corresponds to the bold line on the previous slide. It is set to how much memory you want the Varnish D process to use. And in this case, we're talking about RSS, which is the resident memory size. And by default, you have it at 80%. You can configure it, and you can even change it while you are running Varnish. So you can set it at 80% and say, well, I want to start this other process here and it will take some memory. So let's just dial down the Varnish memory usage for a bit, and you can dial it out afterwards. It looks very cool on the graphs at least. And you can get away with the malloc stevdar, which has a parameter saying how much payload you will have, and you can simply do MSE. And that will make the governor make sure that you're using the right amount of memory, and the governator thread will start removing objects if you are using too much. And if you have not a malloc but a regular MSE, you can just say mem cache size equals to auto, and then things will adjust by having the memory governor. There are a few things. You can only have one MSE and you can't have any malloc, but that's really how you want to do it anyway. In almost all cases, not all cases, but almost all at least. You can have many books in the MSE, and you also get away with many transient problems which have plagued many of our customers previously, where transient is difficult to predict and handle. If you don't know what transient is, that's fine, of course. Right. 9, web application firewall. The question is, why do a level 7 WAF in the cache layer? You want to do it just before your origin, because you don't want to do it in cache hits. And luckily, that's what you do also when you have a web application firewall inside of Varnish. You do it just before you go to the backend and not if you have a cache hit. This means that the cost of doing the WAF is reserved for the cases where you go to the backend anyway. And since Varnish is fast at doing the WAF, this doesn't cost you anything extra. So the web application firewall on Varnish does not have its own rule set, but it does support the Open Web Application Security program, my little project. Yeah, I have a little webcam up there. Yeah, so the mode security core rule set is supported, and to use the WAF, you need to tell it where to find these files. Of course, you can write your own files and you can remove stuff that you don't need from the core rule set. For example, if you don't use PHP, you can remove all of the rules with PHP, and if you don't use SQL, you can remove any kind of rules for that. It will make things easier. And you can, as I'm showing in the second box here, you can skip some requests. For some requests, you can skip the WAF. For example, if you have a separate host, starting with static, where you keep all of your images, you don't have to apply the WAF. And then there's an easy way to do that. Yeah, you also, one of the benefits of having the WAF inside of the cache is that if you have many backends, different kinds, you can all do all of the WAF in one place. And anyone asking if you're a web developer, you would like to not have to do this, yeah, administrator can do that. Finally, this is my favorite point, saved for last. Fine-grained statistics of your traffic. Whose traffic? Everyone's. And this is a bit strange subtitle, and it refers to the fact that many Varnish users have tenants. And if you're a CDN, you have many tenants. If you're a big IT department, you might have different users of your cache, and they're all behind you in a safe environment, and they want their own statistics on the traffic. And I'm going to show you how to do that with Varnish Enterprise. So there's something called the accounting vmod. Sometimes you have to bill. Sometimes you just want to know how much. So you have to do accounting. It's also the name of the Varnish log entry when you do when you look at the log from transactions. And you have the concept of namespaces. You can do that, for example, one per host name or one tenant. And then inside of each namespace, you can have a number of keys. And the main motivation is the multi-tenant case, as I said. And you want to bill each tenant, and you might even have separate VCLs for each tenant. And then you want to partition everything up into these tenants. And you need to create the namespaces in VCL init. Of course, you can have only one if you want that. Straightforward to create. And then when a transaction comes in, you need to set the namespace, which is exactly what namespace am I using right now. And it's done simply like this. And since it has return VCL, it means that you have to load a VCL called tenant1 first. If you're familiar with labels, this is intuitive. If you're not, I can just say that it has to do with having separate configuration for separate parts of your code, typically tenants here. And the last else block, where you have the generic namespace, is when you have a request which isn't associated to any tenant. Such requests are special. They can be your own requests, or they can be simply requests that you want to serve an error. Right. So in general, everyone gets requests that are either script kiddies or illegitimate or somehow unwanted. And then you really want to just serve an error to that. And I encourage everyone to serve errors opportunistically from the cache, for example, if the hostname doesn't match any of your tenants. Yeah, and then when you have done this in each of the tenants' VCLs, you can have different VCL. And this example here shows how you can consult the content type after you get a response from the backend, and you can attach a key, either images or not a hot dog, which is a reference that probably all of you will take. And when you do this, you can see how much traffic of which kind happens for images, and which happens for not images. And in this case, where you add in backend response, you also need to add some code in VCL deliver or VCL synth, but that's just a detail. The essence is the same. You're able to partition your traffic in many ways. You can do this with images, and then you can also partition on other properties of the requests. Right, so what are the counters you get from these? Well, this is a list. These are all the counters for each namespace key combinations. You get all of these counters. For example, you can see how many requests you have. You can see how many bytes, body, header bytes in the response, and you can see the hits and how many bytes and you have different kinds for the hits, the misses, the passes, and so on. And you can also see how many errors of different kinds you have and how many 200s. So all of these counters might help you understand the traffic. You will be able to create dashboards for the different tenants and gain insight about your traffic. It takes a while to set up, but with this, you can get something you couldn't get without it. Previously, you would need to post-process logs to be able to see that, and now it's possible to create dashboards and see these things live with the accounting. Yeah, that was it. I'm 10 minutes past what I decided. Oh yeah, good questions. I have two questions. First, I'll take the last one first, which is about the counters. And the question is, are the counters persisted somewhere? How are they reset? And the answer is they are not persisted. Typically, you want something like Prometheus to scrape these things. And with Prometheus, you have a database, time series database, and it can do aggregation between different servers if you have a cluster of these. And you can use Grafana to graph it. And there are tools which does this very well. And we didn't want to reinvent the wheel while doing this. We might reinvent the wheel later, but right now we have seen that using tools like Prometheus and Grafana works, and you can persist it using through those means. Yes, that's this question, and the first question was about GoTo, and the question was, how quickly will GoTo.dns director handle a change? Will it redo the lookup when a request fails? And the answer to this is that, as I mentioned, there are lots and lots of options that you can provide to GoTo about how long you want these lookups to be in the cache. We have a DNS cache. We don't want to do a DNS lookup every time. You want to have a timeout for this. And if you need to redo the lookup, well, sometimes that doesn't make sense. In DNS, things are generally slow to update and flaky. And you have many places where you do a lookup, DNS lookup, and then you do the same 20 seconds later and get an empty response. And in these cases, we say that, oh, the last, at least that if you configure it as such, you'll use the last sane reply you got. And there's been quite a lot of development there, but DNS is messy. And in general, we try to solve that as good as we can and give the options that make sense. Everything is documented on our docs site, docs.varnishsoftware.com. There you can click your way into GoTo. Probably searching for GoTo vmod Varnish will also send you straight to the right page. That's the second question. Good questions. I'm going to go back here and show you my email address again. Yeah. I missed the first 5. Will it be possible to share the recording? I'll let Alex answer this if it's possible. Yeah. Okay, I've got another question here on chat. The question is, if a user requests a video that is not in the Edge server, then if the file is a large MP4 file, Varnish will not deliver it until it has the bytes that are requested. Is there a way to pipe the request until the whole video is downloaded and then switch to Varnish to stream the MP4 video? Is there a vmod that handles MP4 videos or something similar? Well, range requests, those are hard. If you have a range request in the middle of a large asset, like a file, like an MP4 file, Varnish will start fetching everything from the beginning and put everything in the cache. And as soon as it gets the bytes which has been requested, it will start streaming them until everything that was requested has been sent to the client. This is true by default. The problem is, of course, if you ask for a bit in the end and need to load everything, and then that object is evicted, and then someone does the same again, and all the action is at the end, then you'll have a problem. We are working on an extension to Varnish Enterprise called the slicer, which is a way to handle range requests in a better way. And when you do this, you can have pieces of a big MP4 file in the cache while other pieces are not, by using the slicer. It's not been released yet, but I imagine it will be here soon, which is Q3. Yeah, that's my hope, at least, as the release manager. It is going through review now, and we might merge it real soon. And then it will be in the next release. But yeah, that's the big question. Large files in general is something that we do not encourage. We encourage people to do segmenting. That's the best way of serving large video content, but the slicer will solve to a large degree the case where you have huge MP4 files. I hope that answered the question. I will assume it answered the question. That seems to be the last question for now. Yep. Yes, so the answer to the question about the video, yes, it will be shared tomorrow. This video will be shared tomorrow. Okay, thank you to everyone attending. Have a nice evening or day, depending on where you are. Goodbye.